Hello, everyone. Thank you for joining me today. I am really thrilled to be here today and talk about parallel and concurrency programming in Node.js. Where is this? This one? Doesn't see.
Can you change on the laptop? Because
Okay.
maybe it's
Yeah.
not recognized.
Yes, yeah, I can do it. Okay, then. Okay, just a brief introduction of me. I am Egzona Vllasaliu. I am a software engineer at Fractal, part of Concurrency. I have been working with mostly Node.js on the backend side. So what we can expect from this presentation is to go through some of the fundamentals of parallelism and concurrency, some techniques and tools to implement them, some real-world examples and case studies. Also, what are some best practices to implement them, some performance metrics and optimization, and we will go through pros and cons of implementing concurrency and parallelism in Node.js. So, parallelism and concurrency are some concepts that were first introduced when we wanted to create operating systems. So after that, many programming languages tried to adapt and implement them into their environment. Other than that, concurrency and parallelism were some concepts that became fundamental for distributed systems. So what it is, parallelism? Parallelism is a concept or is a process that assures us that we can split up a task and that task can be executed in parallel in different resources. As we can see here, we can have, for example, multiple CPUs. In this case, we have only 2. And if each CPU can have multiple processes and a process can have multiple threads. In this case, a task has been split into some subtasks that are being executed simultaneously. While concurrency, as we can see here, we have a CPU, and in this CPU we have one process and some threads. What is the main point of concurrency is that it can allow us to execute multiple tasks while they can be overlapped while being executed. The main thing is that concurrency is being used when we don't want our CPU to have a idle time. In this case, for example, we have a task on thread 1, and if it is being executed, but at some time we need some input-output wait, then the other thread is going to concurrent or do a race with other threads to get the CPU allocation in order to be executed. So this is a main definition of those two concepts, but how does Node.js implement them? To understand that, we need to know first that when we have a Node.js application running, what is going to be created is one process, one thread, one event loop, one JS engine instance, and one Node.js instance. On the right side, we can see a structure of this, but what is the main point of this? That is we have only one thread. And what we saw in concurrency is that we have to have multiple threads that are going to execute the task as they come. But in this figure, we can see that we have multiple users that are trying to access our application. So what does Node.js use to implement concurrency is exactly event loop that is going to help us implement concurrency. So by default, by its nature, Node.js uses event loop to implement concurrency. To make it simple, we will go through this with some illustrations. So concurrency in Node.js is accomplished using asynchronous programming. which can be callbacks, promises, and async await. As we can see, event loop has some components like call stack, microtask queue, and microtask queue. What is going to interest us is microtask queue in the example that we are going to take because of the things that it handles: promises, callbacks, and async functions. So as we can see, we have some tasks here, and they are, for example, all on the microtask queue. And when we try to get some resources, what is going to happen is that in the moment something is being accomplished in the microtask queue is going to be put in the into call stack, and then we will get the response. So in this case, Node.js doesn't wait for, it doesn't let its user wait for a response, but takes as many requests as are sent to it. If we focus in this code, the order of what we are seeing right now is that we have an arrow function called 1, which is going to resolve some text, a string 1, and then we have a block of code which is called my function, and it has some tasks in it. The other thing that we see is we are going to have a console log before function. We are calling the function, and then we are consoling log after function. If we try to see what is going to be printed into our console, as we can see, if we don't know how event loop is going to work, we are suggesting that the result will be before function, then it will be in function, it will be result 1, and then we will have after function. But what is really going to happen is that we will have this result. So 1 is being console log the latest. So what is happening really in this case is that first we are going to have before function in our call stack. In this case, this is going to be executed first. What is going to happen next is that we are going to invoke the function. We are calling the function myfunc, and in this case, we are going to have it in call stack. As we can see, the command that is going to be executed is the console log in function, as we can see in the console. After this, we have to await for function 1, which is a promise that needs to be resolved. In this case, from the call stack, we are not blocking our main thread, but we are putting this function into microtask queue. So in the moment this is going to be resolved, we are going to the next line, which is after function, which is going to be printed in our console. And after this, we are going to have our function back to the call stack, and we are going to print the result we get from the function, arrow function 1. So that was concurrency that is implemented by nature in Node.js, but parallelism is not something that is implemented by default in Node.js. So in order to achieve this concept in Node.js, we need to use something extra, if we could say, which are worker threads. As we can see on the left side, we have standard process code, which has a process, a single thread, a JSNG, Node.js instance, and then we have our code. So what happens with worker threads is that in this case, we are trying to copy instances of our application. As we can see in this case, we have 3 instances of our application, which each instance is going to have its JS engine, one single thread for that worker thread, and then we are going to get back our result. Other than worker threads, there is another concept that we can use to achieve parallelism in our code, which is cluster mode. In this case, as we can see, if we don't have cluster mode, then on the left side, we can see that when our application is up and running, we are going to use only 1 core of the CPU. So in this case, all requests are being forwarded to a single processor core. What is the problem in this case is when we have, for example, highly computing tasks. In this case, our main thread is going to be blocked, which we don't want that to happen because this is going to cause a lot of latencies on our application. But with using cluster, as we can see, cluster mode comes with a load balancer itself. So what is going to happen in this case, we are going to have, or we are going to use all the threads that can be created from the CPUs that we have. In this case, the core one is going to, for example, this is going to be, we are going to have a main thread that is responsible for distributing the requests that may come to our endpoints. What are some real-world examples when we use parallelism? As we can see in this example, we have used worker threads to achieve this parallelism while we have a task that is called, for example, image processing. What we want to have, for example, we have some images that some users have uploaded. What we are going to do is, for example, we are trying to transform them. And in this case, we don't want the users to, for example, we want them even to get the response back, but also be able to work on other things on the application. So they are going to transform their image, but at the same time that, for example, they can comment or do whatever we have on our application that is implemented. How we did this is using events on the Node.js. As we can see, work on message. We are going to resolve whatever we are getting back from the function. As we can see, in fact, is a file, another file that we are going to see is imageworker.js that is going to use the maximum number of CPUs that we have available. The task is being completed in that way that we divide in chunks images, and then those chunks are going to be proceed using sharp library in Node.js, more specifically using Express. And in this case, we have used something that is called parent port and worker data from the module worker threads. In this case, when the images are being transferred, what are we going to do is that the output file that we got from the sharp library with all the transformation that they have did, we are going to post to our main thread in that case to send back, for example, to the users that want to see their proceed image. So this is the case when we want to use worker threads, which is more special because it is something that we need to use some additional libraries to achieve this. But we have cases when we want to achieve concurrency in a better way that, for example, Node.js provides. Let's take an example about web scraping. In this case, we have different URLs, for example, that we want to get titles of whatever post they have in their websites. In this case, we are going to use promises, and the moment we are going to get the result back from, as we saw, the event loop, we are going to use a Cherio library that is going to allow us to get the titles from the response data that we got back. Those two concepts are really important and kind of hard to implement when it comes to parallelism more specifically. But what are some companies that have used and successfully implemented them? Are Netflix, Walmart, and LinkedIn. More specifically, Netflix has a enormous number of requests from different users and millions of users for some period of time. And how they have handled this is by using concurrency in Node.js. Also, they have they have used some best practices to implement this. What they have done is identifying tasks that need parallelism. Not everything in our application is going to need to be executed in parallel. So what does this mean? Is that we have to identify only those that need parallelism in order to give us better performance. Also, Netflix has used, for example, microservices for concurrency and scalability. In our application, if we have millions of users that are trying to get some responses back from our application, for example, we will have only a number of endpoints that that are going to be hit by our users. In this case, it is better to give some more resources only to them and not to the entire application. Implementing proper error handling is something really important in this case, because when we use or when we implement parallelism, it's really hard to debug when something goes wrong. When something goes wrong, we mean, for example, a process that is running or a worker thread has been killed or exited. In this case, we are not going to use to lose any data, but we, for example, are going to fork new resources for it. Monitoring performance is something really important, because having a lot of threads and especially in our application, can be really hard to be maintained. What does this mean is that Node.js is not a multi-threading library. So in this case, we cannot use synchronization of threads. If we cannot do this, we can occur in some problems. What can be some problems on this is race conditioning. And with race conditioning, we have problems that we need to implement, for example, different algorithms in order to prevent this race conditioning. So not every time we implement parallelism, we are going to need all the threads or CPUs that we can have on our machine. So why does this happen is because of, as we said, race conditioning. Some threads are going to try and use each other's resources. And in this case, for example, if we have 3 threads, as we saw before, if thread 1, for example, is trying to read some data for a variable, and the thread 2 is going to modify that value, then the processes or calculations that are going to be made on the worker thread 1, there is a risk that is going to use, worker thread 1 is going to use the old data and not the ones that we wanted to modify. Optimizing parallelism is exactly what we said. We don't always need all the threads that we can get from our CPUs. Optimizing concurrency is more exactly when we work with callbacks. Callbacks, as we know, can be dangerous in the aspect that we can end up in callback hell. And here what can be done is that we can just convert the syntax that we have with callbacks to promises, or even better with async await syntax. Or there are third-party libraries that we can use. For example, for asynchronous techniques, we can use library which is called async, while for parallelism, there is a library called parallel.js that is going to help us with the problems that can occur while implementing parallelism. Pros and cons, definitely using parallelism when we have heavy computing tasks is going to improve our performance and for CPU bounds and input-outbound tasks. We will have better resource utilization. What does this mean is that we have a multi-core CPU, then we use, for example, a node, only a node instance. In this case, all the other resources are not being used. We just spending money on the other resources. Also scalability. We mentioned that we can have, for example, when it comes to number of requests that we can handle on our application. In this case, we are going to have a better handling of those requests. Cons of implementing, especially parallelism, is that we are going to have a increased code complexity. We will have to manage our threads and CPUs, and not all tasks can benefit from parallelism. So in this case, always try to use performance metrics, like, for example, perf hooks, which is an NPM package that we can see our time execution of our code application. In conclusion, concurrency is something that is by nature implemented in Node.js. But parallelism can be really useful for us when we want to build fast and efficient, scalable applications. As this field is going to continue to evolve, we are going to have and expect new techniques that are going to help us with implementing, especially parallelism. That's all. Thank you.
Thank you very much, Egzona, for the insightful presentation. Are there any questions? I see some questions up there. Can we pass the microphone? Do we have a microphone up there? No? Okay. I wasn't looking at you, but okay. As the microphone is on the way up for the question, we can take some questions from around here. Yes, we have a question in the middle row. Can we pass the microphone over there, please? Perfect, thank you.
So basically my question was about the example of web scraping. Can we use concurrency concept instead of parallelism? If yes, when I will decide which one to use over the other?
About the example about image processing, the main goal is to use parallelism. Why? Because if we have a lot of images that we want to transform, as I said in the presentation, for example, we want the user to be able to do other stuff while we are proceeding with its images. In this case, if we use concurrency, we can use it. But what is going to happen, it is that is going to block our main thread. In this case, for example, it is not going to be able to handle other requests until that one is being finished.
Okay, thank you.
Thank you for your question. Meanwhile, we can take the question upstairs. We didn't have a question. Someone just wanted to wave at me. Okay, I'll get used to that, fine. We have a question here in the middle, meanwhile.
Hi, and thank you for your presentation. What's your advice on having to deal with race conditions? So when we do the concurrency, it's almost inevitable that someone will run into a race condition when something finishes before something else is expected. So what is your advice on approach to solve those issues?
When it comes to race conditions, there are basically some algorithms. Node.js by default uses round robin to do the job scheduling. What we can do to prevent race condition is that every time, for example, we create threads for our application, we try to maintain or try to use the performance metrics to see if that parallelism that we are trying to implement in our code is making it better or worse. Sometimes parallelism can do worse things than using, for example, a completely different approach to that problem. Node.js before used to support locks and mutexes, but since it is not a multi-threading environment, now it doesn't, so we have to find, for example, try to implement our algorithm or use the built-in libraries that we can have for implementing parallelism.
Thank you. Hopefully that answers your question. We have time for a couple of more questions. One over there, please. If someone can bring the microphone towards the back in the middle. Orange sits. Orange sits over there.
Hi, great presentation first of all. So I have a double question basically. The first part is about worker threads. Do they share the memory or is every worker thread completely independent? And the second part of the question is about parallelism. Which method would you recommend, worker threads or the other one?
Thank you for your question. When it comes to the first one about worker threads, as we saw in the presentation, they can pass messages between threads. So they can have a shared array buffer in which they can post messages. And as we saw, for example, on the image transformation, in this case, when the image is being processed by a worker thread, that thread is going to post a message to the port parent, which is going then to send back the response. So they do have a shared memory when they can access the data they are proceeding. But they cannot transfer, for example, other variables or data that can be objects or other data types. The second one was about do you prefer worker threads or the other library that we can have clustering. In this case, I would say that both of them are for their main purpose. For example, worker threads are more for the things that we said, sharing memories and accessing data from one another. While when we have, for example, clustering, basically it is going to use as we said, all the CPUs that we have, and then use or calculate what it is going to do. But I wouldn't say one is better than the other. So we need to use it based on our case more specifically.
Okay, since the question system got cheated and we got double question, I think this is all that we can afford time-wise for the questions. So just one round of applause for Egzona one last time. Thank you very much.